Rightio guys, this is the first in a series of movies, I can say either, about indices and their coefficients. So basically today's video is going to be what do we do if we run into a situation where we have numbers. So if we look at this one here, we've got our a squared and our a to the power of 3. So we're very familiar with the first law and knowing that all we have to do with those two numbers is of course add them together, and that gives me a to the power of 5. But what do I do with these two things? Well, funnily enough, whenever I do these, I see it as two separate questions. I've got a number question, so in this case it's going to be 2 times 3, which gives me the answer 6. And then I've got this index question here, which means I just add our two indices. And so you can see quite clearly here that 2a to the power of 2 times 3a cubed is equal to 6a to the power of 5. So let's go and have a bit of a look at what happens when we've actually got numbers as bases. So if you remember, this is our base, and of course the little number up the top is our index. So if you remember, our first thing we learned in indices is that if the bases are the same, so in this case it's 2, then we can take our powers and we can add them together. So 2 plus 4 is going to give us that answer of 2 to the power of 6. Now 2 to the power of 6 we can actually write as a number. So that's actually 2 times 2 times 2 times 2 times 2 to the 6 times. But we can also change these ones here into numbers as well. So 2 to the power of 4, 2 to the power of 2 is 4. And 2 to the power of 4 is 16. And of course 16 times 4 gives us the answer of 64. And that of course is what 2 to the power of 6 is. So we can jump in between numbers and indexes. In this case it was much simpler for me to go to this step because of course I had bases that were the same. And if you're looking along, I'm pretty sure you can see the next question answers what some of you might be thinking now. What do we do when there aren't bases that are the same? Well, in this particular case I can't add these two numbers together because I've got a 3 and a 2, but as I said, I can of course go back to numbers. So 3 squared is, remember, 3 times 3, and then I need to times that by 2 times 2 times 2. Now I know that 3 times 3 is 9, and I know that 2 times 2 times 2 is 8, and of course 9 times 8 is 72. So you can see that we need to be careful with our numbers, but we already know how to work with these particular things. We've worked with them before. This particular question, please be aware that 3 has a power of 0, so even though it is the number 3, if I raise it to the power of 0, I actually change that to 1, and 1 times a squared, well, that's one lot of a squared, or simply a squared. Now the last one I want to look at before I move to another video that's going to look at a thing called a common factor is what do we do when we've got numbers involving our second index law? Well, if we think about it, once again, if we go back to here and treat it as two different questions, first off let's treat it as a division question. So 10 divided by 2 is going to give us the answer 5, and then of course if we do an index thing, we know that the second law basically states that if we're dividing then we're going to take the powers, and so we get 5 to the power of a. That was a very quick look at what we do when we get numbers, and the next video we'll be looking at what happens when these two numbers don't divide as evenly or nicely as they have in this particular account, and that's when we have to consider a thing called a common factor. Just like to thank all my listeners out there, especially Jesse Connors. Can you stop subscribing, Jesse? It's getting embarrassing.